This time, we reveal how city planners keep millions on the move.
Everything is instant, everything has to be now. City life is, I want it, I go and get it.
From the extreme climbers maintaining San Francisco's Bay Bridge.
All you have to ask yourself is, well, does my family, does my wife and boys go over the bridge? How much do I value their life?
To the hidden army that keeps London's buses running.
You have to make sure everything leaves on time, all routes, all services. There's hardly any gap in any service.
And scientists fighting the crisis with inspired solutions for the future.
It's something that's going to transform the world, and it's something that's going to happen. It's not a dream, it's going to happen.
Half the world's population live in urban areas, and the number is rising every second. Each day is a race against time to house, feed, water, and move more than 3.5 billion people. It's an impossible daily challenge. The slightest glitch can bring a city to its knees. And every 24 hours, it has to be done all over again. This is the story of how cities work. San Francisco. Every day, tens of thousands of commuters pour into the city over its two bridges. The busiest is the San Francisco to Oakland Bay Bridge, which carries over 250,000 cars every day. But like every structure in the Bay Area, it's under attack from a natural enemy: rust. Today, an inspection team is heading for its massive western span. It's a high-risk operation for Rachel Donovan and her team.
All kinds of terrible things could happen. So everything height, if we were to drop something and if it were fall into traffic, you know, it would easily break a windshield. So one of the things we're doing, in addition to making sure we have all of our safety gear for ourselves, is we're making sure that everything we have is tethered on a string of some kind.
Anything could become a lethal projectile if dropped. From up here. They're aiming for the top of the towers, which soar 160 meters above the bay. There aren't any lifts. The only way to the top is up a cable that's just 80 centimeters wide.
As you can see, it's a little difficult walking on the cable. You know, we're walking on a circle basically, so trying to stay on top of it. It's not very wide.
At this height, any fall will almost certainly be fatal, so they're clipped on at all times. As they get higher, the risk increases.
And as you can see, the cable starts to get steeper and steeper as we reach near the top of the tower, so it makes it a little bit more difficult once we get closer to the tower to hike up.
After the long climb, they reach the relative safety of the summit. Now, the real work begins. If left unchecked, rust could force the bridge to close, cutting off the city's most important commuter link and endangering the lives of those who use it.
Our role in the maintenance of them is to find defects. In most cases, we don't find anything real bad. That's the whole idea of maintenance. When you're finding something small and minute, get it fixed then so it doesn't deteriorate further and become a full-blown issue.
To find those defects, there's only one way to go: down. And this time, they won't have the safety of the cable under their feet. They'll be abseiling. Chris Elbow is an experienced abseiler, but he and his teammates still have to look out for each other.
Periodically, you have to check your buddies' gear and as you're checking your own. So a lot of times when you're out here, you're out in the sun, you've been climbing a few hours, you might miss something, so it's always a good idea to check each other's work.
And if things do go wrong up here, they're on their own.
We are already in the event of an emergency to rescue each other. Someone could rappel and help the other person who is on the rope, perhaps if they are unconscious or whatever. We are trained for first aid CPR, so we can provide that right on the spot.
The two-man descent team is finally ready. If anything's going to go wrong, it's likely to happen now. Just a few meters down, Chris detects a problem. His safety rope is caught up.
You know what, I don't like this.
His team looks on helplessly. Moments later, his rope untangled, Chris is safe to continue. While traffic thunders beneath them, the inspectors record any corrosion on the tower face. For Edward Tometz, the importance of what they do outweighs the risk.
All you have to ask yourself is, well, does my family, does my wife and boys go over the bridge? How much do I value their life? There you have it. That's how thorough I'm going to be.
Finding corrosion is only the start of the job. If it's not dealt with, rust will eat away at the structure. So Chris and the team call in the paint crew to tackle it. Today's job, a patch under the main highway. To fix it, the paint team need to get to it. But the only access is from the road itself. Shutting down the bridge would cause chaos.
Without this bridge, it would probably cause numerous backups on the other arteries.
So they close a single lane.
This is a very risky job, considering that each driver that passes through is a potential hazard for us in terms of wiping us out. I've seen several accidents since I've been here, little less than 2 years.
This time, no such trouble. And it's over to the paint crew. Between them, Randy Crawford and Floyd Lacey have over 14 years' experience on the bridge.
Worst enemy is probably the weather. The fog comes in and it just sits on it. And that's what creates the rust.
They call it volatile organic compounds. Salts, burn crap, smog, all those things mixed with the moisture and set on the steel and heat it up. We get a low charge through the bridge that's caused just by the wind and the currents. You get electrolysis at the bottom of the metal. You get all kind of things acting on the steel to tear it apart.
It's a dangerous job. They have to clip on to avoid falling. But that's not the only hazard. The old paintwork contains toxic lead. So they have to suit up in protective clothing. Once ready, it's time to apply the protective red primer. To reach this stage, they've already spent a week preparing the surface.
It's a lot of work, a lot of hand tools. The other days were, like I said, on our knees, on our back with hand tools, grinders, roto hammers, needle guns. Working the iron. It's loud, it's dusty. Then we're wearing different respirators with air fed to keep us safe from the lead.
The protective clothing makes a tough job even harder.
It's stifling. You're in a sauna, your shoes will fill up with water, your sweat. I lost 12 pounds my first month last summer, just doing that.
Once the primer is on, Floyd and Randy will use a special kind of aluminium paint to protect the steel from corrosive elements. Once finished, this area should remain rust-free for the next 15 years. The war against corrosion will never be over, but for Floyd and Randy, there is a plus side.
This is somewhere not everybody can be at. This is a kind of amazing thing to me to be working up here.
The best views in the bay, though, being up here all day long.
Rust is a menace. But the bridge faces a far more instant, catastrophic danger. It can wreak havoc in seconds. And tackling it will take way more than a simple lick of paint. San Francisco sits on two major fault lines in the Earth's crust, placing it in the shadow of a constant threat: earthquakes. On October the 17th, 1989, a 6.9 magnitude earthquake ripped through the Bay Area. A 250-ton section of the Bay Bridge's eastern span collapsed. A driver was one of 63 fatalities that day, and the bridge was closed for a month. San Francisco will experience another earthquake. When it does, it can't afford to lose the use of this major commuter link again. The solution? To replace the old eastern span with a whole new earthquake-proof bridge. The man commuters are depending on to deliver it is seismic engineer Marwan Nader.
The old bridge obviously was built in the 1930s. And back then, as engineers, we did not have a good understanding of what earthquake loads are like.
This is one of the most advanced bridges in the world.
Today we have a much better understanding of that, and we have a good understanding of ability to model these and analytically analyze them in terms of forces and displacements.
Nader and his team have designed a structure that looks like a regular suspension bridge, but it's packed with life-saving innovations. Andrew Gordon, a manager on the project for 5 years, is familiar with its hidden inner workings.
This is, one of the most seismically advanced bridges in the world, and it's been designed to withstand the largest possible ground motions from an earthquake within a 1,500-year period.
These internal tunnels will be key to the bridge's survival.
People think of bridges as probably being solid structures, but there's actually these tunnels running through the bridge decks of the new East Span, and that's for routine maintenance, just ongoing upkeep of the bridge, but also in the event of an earthquake, workers can come inside and check for damage on the inside of the bridge as well as on the outside.
Marwan and his team used computer models to predict where that damage might occur.
The computer analysis that we did models the geometric stiffness of all the elements, and all the forces and the stresses and the strains are captured. What we see here is what's going on underneath the roadway, where the expansion joints are going in and out, closing in and out about a meter, meter and a half, and this is the hinge pipe beam that's keeping the two roadway structures together.
They're basically large metal dowels, and they're designed to act like the bumper on your car or even a lightning rod. They're designed to fail. They are here to absorb and take damage from the earthquake to protect the rest of the bridge. So that's why these exist, because these are easy to access, easy to fix.
All of this hasn't come cheap. It's taken 15 years and cost $6.4 billion to build. But with human lives and city transport links at risk, it's money well spent.
So much has been built into ensuring that this bridge can withstand any size earthquake, or at least the largest earthquake within a 1,500-year period. So again, if there is an earthquake, this is probably where you're going to want to be.
Most city bridges exist to allow huge numbers of cars to get into and out of them. Once in, sooner or later, the cars have to stop somewhere. 1/3 of all city congestion is caused by people driving around looking for parking spaces. It's a massive global problem. Here in Birmingham, in the industrial heart of England, engineers have come up with an ingenious solution. Up to 2,000 people live, work, or shop in the city centre's Cube building. Parking should be a nightmare, but thanks to revolutionary new technology, it's far from it.
The primary driver for us was making sure that this building at its base had retail spaces and things other than a big car park entrance with a ramp.
In conventional car parks, almost half the space is used for access rather than parking. So the designers here did away with the ramp altogether. The car park parks your car for you.
Well, the car park here is a bit different from the traditional car parking system. You park in one of 4 garages, swipe your card, and then machines take your car away and park it for you.
A robotic sensor checks that your car is in exactly the right position. Then a lift takes it to the parking level, where it's spun through 180 degrees, so it's ready to drive straight out on leaving, and transported safely to a parking space. More than 320 cars can fit into the limited space under the Cube. The system is run entirely by computer, requiring virtually no on-hand human supervision. Just 2 maintenance visits a month by specialist engineers.
It's very good. This is the first one in the country of this size. It's the first palletless system of this nature. It's basically, the system runs itself pretty much. It has no manned personnel at any time. If there is any slight problems, they'll call us and we can operate the system remotely, and it's fully self-sustaining.
To retrieve your car, you simply swipe the card. The robotic lift collects it and brings it to you. Cities all over the world are starting to catch on.
When we were researching this technology, we went around places like Barcelona, Budapest, where they're used a lot. I think because of the demand on city space, actually, that they will have to get used more and more.
Robotic car parks may work to solve part of the problem. But the number of drivers on our streets is still increasing at a worrying rate. When the car was invented, it revolutionized the way we think about travel. There are now over 1 billion worldwide. They've become victims of their own success, especially in cities, where people are becoming tired of their dominance.
Metropolis, big cities, they all have the problem that people are driving one person in one car. If you look at the statistics for London, for example, it's like 1.2 persons per car, and that's not sustainable.
An extreme solution would be to banish the car from cities entirely. In Berlin, engineers think they have a better idea: to eradicate not the car, but the driver. If cars drove themselves, more people would use them like taxis. There would be fewer on the roads and cities would flow more smoothly. Here, the driverless car is no sci-fi dream. It's on the road in the heart of the city. Today, safety driver Fritz Ulbrich and his co-pilot Sam Schaher are test driving this revolutionary new vehicle in one of Berlin's busiest and most iconic locations, the Brandenburg Gate.
Okay, then 3, 2, 1, go. And the car's driverless. And I'm not touching anything at all, not the steering wheel, not the brake or the gas.
This is a fully automated car that can see, think, and drive on its own. The onboard technology was devised by Berlin Free University's artificial intelligence expert, Raul Rojas.
What you are seeing here is the brain of the car, if you want. We have a GPS navigation unit. This is for locating the car in the city and knowing where it is. We have computers, several computers. This, for example, is for processing the video cameras. The laptop on that seat, that's the driver. The computer decides which is the best command. Should I stop? Should I accelerate? Should I take the next corner?
Putting a computer in the driver's seat could change urban car usage forever.
You can go with several people at the same time so that nobody's driving, everybody's enjoying the ride, and everybody's going faster because there will be less cars in the streets.
It's a bold vision for the future of transport. Out on the road, the car is getting to grips with its surroundings, using a remarkable piece of technology.
This is a very special laser scanner because it sends 64 rays of light towards the environment. We get 1 million measurements per second of everything around the car, so that the computer can make a three-dimensional reconstruction of the environment.
All of which is fed into the central computer.
What I can see on this display is it's actually a three-dimensional view of the road we're passing and the cars that are nearby. The ones that are interfering or plan or are directly in front of us are marked in red.
Sam keeps an eye on other vehicles. Not because the robotic car is unpredictable, but because his fellow humans are.
There are many things that can go wrong in traffic because it depends not just on you, it depends on the rest of the drivers that they keep the rules. And computers are very good at keeping the rules actually, so they keep the lane, they keep the distance. Humans are not very good at obeying the rules. They always go into your way. If they see that you leave a big gap in front of your car, then they try to occupy that gap.
Fritz must remain alert.
I still want to keep my hands close to the steering wheel because I'm the safety driver and I'm not here for fun. If there's some situation where there could happen a crash, I have to take over control because we don't want to risk anything.
As they get deeper into the city, the risk level increases.
And I have to concentrate a little bit, so watch if other cars come too close to us, like him. What is he doing? Yeah, he was changing lanes without looking and turning on the turning signal. So I took over control because I wasn't really sure if the car would have avoided it.
There's a lot of responsibility on Fritz's shoulders.
We always have a safety driver behind the steering wheel when we are driving because this is a requirement from the city of Berlin. the person will not be doing anything, so we'll be just watching the car.
Despite the dangers, this mass of moving cars and pedestrians is a perfect training ground for the development of driverless technology. But there's one familiar urban obstacle the car has yet to understand: roadworks.
Okay, right now we are in the middle of the city, and right now I'm a little bit nervous because there's so many construction sites. And I have to take over control because of this construction site here, because the car wants to go there. And it thinks there is a lane because in its map there is a lane there, and it's occupied by a construction site, and the car does not know what to do.
It's critical Fritz is able to take over at a moment's notice. The slightest collision could cause thousands of euros worth of damage to the car's sensors and computer equipment.
This is a very expensive car. The total cost just of the hardware is like 400,000 euros, and we have put the work of 20 people over 6 years.
Driving around roadworks may be a current challenge for the car navigation system, but the team is already working on a solution.
Future research, we plan to address this by creating a dynamic map where informations like construction sites are got from other cars, from other drivers, over car-to-car communication, or from the construction site itself.
Driving through busy traffic is one half of today's test. To develop the car's full driverless technology, the team set up camp in the grounds of the now disused Tempelhof Airport.
We need to test at Tempelhof Airport because it's a big space. There is nothing there, so we can drive safely. Every piece of new technology is tested first in the computer, in computer simulations. Then it's tested in Tempelhof with no people, no cars, with just a big plain space. And then when we are confident, we go to the streets.
This wide open space allows the car to drive at speed, enabling its software components to be tested.
For today, I think the testing was very successful and
unusually successful. But sometimes failure is success if you find the error.
A few more years of development are likely before driverless cars will hit our roads for real.
Every day we test very intensively because for getting this kind of technology on the road, for having it as a commercial product, you need to run thousands and even millions of kilometers on the streets and then show that it's safe.
But for Rojas, the wait will have been worthwhile.
Something that's going to transform the world, and it's something that's going to happen. It's not a dream, it's going to happen.
Keeping traffic moving within cities is one thing, but as our world becomes more interconnected, high-speed travel between cities is increasingly important. Spain's two biggest cities are Madrid and Barcelona. For years, overland travel between them took a whole day by train, so people tended to fly instead.
The communication between Madrid and Barcelona was done mainly by plane, because we had what we call the aerial bridge between Madrid and Barcelona.
But air travel has a serious drawback.
If you go to a plane, you have to wait, you have to go through different security controls and things like that.
For business travelers, time wasted is money lost.
We needed something more efficient.
That something was high-speed rail. Over 3.7 billion euros were spent laying 804 kilometers of specialist train track. The trains that go on these tracks can travel at the speed of Formula One racing cars, making them some of the fastest in the world. Dozens depart each day from Barcelona's Sants rail station.
Y en este momento tenemos la mayor intensidad de tráfico ferroviario punto a punto en Europa. Más de 5 millones de personas utilizan al año la línea de alta velocidad. Y estos 57 trenes diarios mueven entre Madrid y Barcelona.
Before high-speed trains arrived, this journey took 7 hours by rail. That time has been slashed to under 2.5 hours by trains that can travel at 300 kilometers an hour. Those speeds would be impossible if it weren't for the work done here, the Santa Catalina Rail Depot in Madrid. It's a maintenance hub for high-speed trains on the network, and one of the biggest of its kind in Spain. Every night, trains arrive for essential checks and repairs, but the engineers don't have long. Many of the trains have to be back on the tracks and transporting passengers by the morning, so they work through the night. The wheels suffer greatest wear and tear.
After it's been in a hard contact with the track, what you need to do is to give it its original shape, or giving it a profile, that is how we call it, so it can run smoothly over the track at speeds over 300 kilometers an hour.
Imperfections in the shape of the wheels cause loads on the axle and suspension, so their original shape has to be restored using a lathe. To save time, it's done on raised tracks without the need to remove the wheels. Before the train can leave, engineers also have to deal with its other major safety feature, the brakes.
The train has two main braking systems. One is the electrical one, and the other one is the mechanical one.
Both systems must work together. The electrical brakes slow the train by reducing the energy emitted from the motor. But to halt the train completely, the mechanical brakes have to be employed.
If the driver is using the mechanical braking system, these two pieces will come together and press the disc and take the train to a complete stop.
This takes its toll on the pads and brake disc, so they have to be checked frequently.
Normally, to take out the brake pads, it will take 5 minutes. But then if you have to take the whole disc out, it will be a major operation.
The effort is essential, as it's these brakes that will be needed if the train has to make an emergency stop.
An emergency stop can happen at any speed of a train, even at 300 kilometers an hour. So that will be one of the hardest braking situations that the system will have to go through.
Thankfully for tonight's engineers, it's just the pads that need to be replaced. They're able to finish work before the morning deadline. Spain's high-speed rail passengers are on track for another day. Trains travel from city to city at record-breaking speeds. When they get to their destination, modern stations need to be able to cope with increased journeys and more passengers. In Sweden, Stockholm's main railway station was built in 1871 to accommodate 10 trains per day. Its two lines now serve 550 trains. 230,000 commuters pour into the city every morning. But there's a problem. The station is one giant bottleneck. All southern commuter trains pile into the city on the same two lines. Engineers are under extreme pressure to create extra rail capacity, and the only place to do it is underground. Tunneling beneath Stockholm is a mammoth task. The city sits on a bed of 2-billion-year-old granite rock, so Lars Osterland and his team are having to blast their way through it meter by meter.
We are blasting about every 4 meters, and we have 6 kilometers of tunnels that we are excavating, and we have 2 tunnels. Calculating this together, it gets a lot of blasts. But we do over several thousands of blasts of the whole project.
The project is known as the Stockholm City Line. 6 kilometers of new line running 10 to 40 meters under the city's streets. When finished, it will double the city's rail capacity. To complete the project, tunnel workers must remove over 1 million cubic meters of material, enough to fill up 30 skyscrapers. And they don't have long to do it. The line must be up and running by 2017. To get it done quickly and safely, the explosives team is using a mix of ammonium nitrate, oil and water. When mixed together, they become highly explosive.
Right now, behind me here, we have the equipment for the emulsion, where the explosives are mixed. Therefore, the track behind me is working out as a small factory for explosives.
Precision is everything.
If you don't get the right density of the explosive, you can't ignite it. It doesn't work.
The moment the correct proportions are mixed, the emulsion becomes highly explosive. The team has to work fast, but they can't afford to rush. Any mistakes now could easily prove fatal. Preparation is painstaking.
The whole process of this, the drilling takes about 3 hours to do. Afterwards, we do the charging work. That takes us about 2 hours.
5 hours in total to set up each blast. 300 kilograms of explosive are carefully pumped into 100 holes drilled into the rock face. While Lars and his team place the charges, another crew is hard at work in the tunnels already blasted. Peter Dahl is the project manager in charge of turning this subterranean cave into a working station.
We are in the middle of the new station. Basically, we're standing at the platform, and around us, on that side and on that side, we are going to have the trains.
One of the biggest challenges is to build concrete walls to cover the rock face.
We have about 30,000 rock balls. We have concreting works to the scale of 30,000 cubic meter of concrete.
Workers must create a timber-framed mold into which the liquid concrete will be poured.
After that, we have to put in all the escalators. There are roughly about 50 escalators. All the details, finishing works, electrical cabling, ventilation systems.
Escalators will link the new commuter lines with the existing metro system. When finished, this station will be one of 2 brand new hubs servicing the new City line.
Although we are now in the middle of the project, we still have a lot of work to do.
Peter's job is made even more challenging by the project's location, right below Stockholm's bustling city centre.
There are a lot of restrictions. We have to be within the noise levels, we have to be within the vibration levels, and there are many other factors that we have to be within when we're working in the middle of a town like this.
Such restrictions make the 2017 deadline even harder to hit. They've brought in a team of workers from all over the world to join the 2,000-strong ground crew, including New Zealander Luke Harris.
There's a series of different people that work in here, so we do the groundworks, other guys do explosives, other people do the concrete and spraying across the roof. So yeah, we basically work with the machines and excavators and just do the groundworks.
Today he's helping fit a manhole which will form part of the station's drainage system.
There's a lot of other things that are going to come in on top of what we've done. And obviously if it's not correct, then it has to be taken up and dug up and fixed.
When working to a schedule this tight, any mistakes can be hugely costly. There's no margin for error. Back at the rock face, Lars and his team have set 300 kilograms of charged explosives. The moment they're ready, the area is evacuated.
Now everyone has to move out of this tunnel and get rid of the equipment out of here.
The moment of truth. The blast is a success, bringing the project 4 meters closer to completion. There's still some way to go, so for Lars and his team, there's no time to relax just yet.
This was the last blast for today, and tomorrow we continue in the same way.
Stockholm's transport crisis is a clash of modern commuter needs and an aging infrastructure. Many cities worldwide have the same problem and are having to find solutions. But not everywhere can dig out a giant new underground network. Elsewhere, they're turning to technology. Today, there are more than 1 billion cars in the world, afflicting our cities with a global congestion crisis. This is London, one of the most modern urban environments in the world. But like older cities everywhere, it has one thing that's stuck in the past: its roads.
London, unlike other cities, wasn't designed for the motor vehicle. We're still in the horse and cart era.
The city's aging road infrastructure means chronic congestion, costing the city billions of pounds. The stakes are so high that authorities have created a specialist high-tech traffic control centre, headed up by John Tenton.
If we didn't exist, London would definitely grind to a halt. As a control centre, we work 24/7. I don't think people realise this. So there are people in here all day, all night, monitoring the traffic flow.
1,200 cameras located around the city give its controllers a bird's eye view of every critical junction, enabling them to spot traffic incidents as they happen.
The broken down vehicle, that's all it takes. Or there's a slight accident, or there's some form of incident that stops the free movement of traffic.
Today, Kenny Malin is on duty as a chaotic situation begins to unfold in central London.
At the moment, we've got a major problem at Victoria. No, it's a burst water main. It's a crack in the road. The water main's gone underneath and they've got to repair it. So they're closing the road for 2 to 3 days to repair the main.
Roadworks are one of the major causes of congestion in modern cities. Work here in Victoria is having a knock-on effect, causing gridlock through neighbouring areas.
It has a rather large impact. I'll just show you on the map here what happens. There's the Victoria area there. But anything affecting that area there will also affect Hyde Park Corner, it also affect Marble Arch.
Kenny and the controllers have a long day ahead trying to keep a lid on the chaos. Out on the street, project manager Felicity Luckett and her team are hoping a brand new piece of technology can help ease the pressure.
This is a magnetometer. It's an in-road vehicle detector which we put in the middle of the carriageway. It works by measuring the magnetic field and detects changes in a magnetic field when metal objects such as cars and buses pass over it.
These new units work wirelessly, making the devices faster and easier to install than any other traffic detection system. A single 8-centimetre hole in the road is all that's needed. Once installed, the sensor will help the traffic signal make decisions about when to change the lights from red to green. Cities around the world are experimenting with smart technology systems, but none quite like this.
It improves traffic flow because if we didn't have this information, it would be on a fixed plan and not be able to react at all to changing traffic conditions. And so you'd spend a lot longer waiting around at traffic lights.
Tests show that the system can reduce delays by up to 20%. So London is rushing to extend the programme as fast as possible to all the city's 6,000 traffic signals. Engineers like Nick Ames have their work cut out for them.
Probably done in the last few months, 100. We have a batch of maybe 40 to do, and they usually give us a week or so to do it.
Working at some of London's busiest traffic spots, it's essential he remains alert at all times.
You've got to keep your wits about you most of the time. The traffic is, this is the main thing. You've got to watch out for the traffic quite a lot. People go more faster than you would have thought in a city.
Long term, they hope this will keep traffic moving. But short term, Nick and his team have become part of the problem.
We've got to open up the bus stop again because the people are coming down to do the buses. So we're going to have to be pretty quick on this one, I think.
With rush hour almost upon him, Nick just manages to finish the job in time.
We've got to get going, probably got another 3 or 4 a day, but loads still in the pipeline to do.
Smart traffic control devices like this are being rolled out across the world. But in a crisis situation, there's still no substitute for human intervention. Back in the traffic control centre, Kenny is still battling with the burst water main that's wreaking havoc on the city's roads. He relies on something that other Londoners can only dream of: the ability to turn the traffic lights green. Kenny's colleague Steve Gilmore will have to use that power to keep the city moving.
The timings on that were low, so that now I've gone from 9 seconds up to 42 seconds green. That enables the eastbound traffic to have more time to flow out.
The ability to manipulate traffic signals remotely has helped Steve avert a full-blown crisis. Control centres like this are helping traffic flow in cities around the world. But if city authorities are going to deal long-term with the congestion crisis, they need to find ways to get people out of their cars entirely.
We can't deny that we've got congestion problems, as all major cities have. So if we're taking traffic off the road, we're helping congestion. We're helping everybody to get round easier.
In July 2010, London launched a pilot scheme aimed at swapping the city's mode of transport from 4 wheels to 2, by providing bicycles for easy, immediate hire around the capital.
The idea of the scheme is for short journeys. It's to get people off the buses, off the tubes, and to try and ease congestion on the roads.
The scheme has sparked off a cycling revolution. There are now 9,000 bikes available for use at 450 docking stations around the city.
It's a scheme that works. 23 million trips, people aren't going to use the scheme if it didn't work.
But the scheme's increasing success brings with it a responsibility to keep more people safe. One defective bike could put lives in danger.
It sounds simple, but there's an awful lot of work and a very big workforce behind it. There's always a certain number of bikes that are coming in for repair because of just the general maintenance, and every bike also gets a service at least once a year.
Part of this critical maintenance workforce is based here, at the main bike depot in North London, one of several maintenance depots located throughout the city. Here, defective bikes arrive in lorry loads and into the hands of Turan Hassan, one of the depot's mechanics, whose job it is to restore a bike to working order. But first, he has to find out what the problem is.
Anything that is dangerous, you've got to do, you have to do. You know, if it's a cosmetic, then okay, that's not too bad. But brakes, gear changes, buckled wheels, you know, something that's going to cause you to have an accident, you have to change. You know, you can't just bypass stuff like that.
But one of the first things Turan checks is if the bike is true.
True means it's balanced, it's not wobbling. Because sometimes as you're going up and down curbs or whatever, it can take the balance out of them. Well, you get buckled wheels, broken spokes, cables, then you check the gears. Just going up in the gears, first, second, third. Yeah, that looks true.
But with a guarantee to keep a certain number of bikes always available at docking stations, Turan and his team must work around the clock to carry out repairs.
You try to average about 6-7 bikes a day, depending on what's wrong with them. I mean, some mechanics are really fast. I mean, if the bikes aren't too complicated, they can knock out about 8, 10, 12 bikes a day, which is not bad going. But if you've got hard bikes, you will be getting about 6 to 7 bikes a day.
This group of bikes may be newly restored, but it's only half the battle. Another team of hidden heroes like van driver Mohammed Muhith is out on the street topping up the network's docking stations with newly serviced bikes. It's a physically demanding job.
Basically, it keeps me fit. Well, I push about probably 80 to 100 bikes a day, and I enjoy it. It's a good workout. It'll be quicker. People going fast. People going to here and there quicker than cars. They have to wait in traffic. I mean, there's cycle lanes, so that's even quicker now. And it's improving, so it's greener, isn't it? London's going greener.
We're able to get around easier, quicker, and with less congestion. And if we can all do some of that, and you get the health benefits, what's not to like?
This scheme could bring relief to the troubling congestion in London. But many think the real answer lies in mass transit. 6.5 million bus journeys are made in the capital each day, more than any other form of mass transit system. Its success is dependent on the bus's reliability. If that goes, then people will stop using them. It's 5 a.m. at the Brixton bus depot. While most of the city sleeps, Brixton's bus workers are already hard at work. Depot controller Sharon Moses faces a massive challenge to get 100 vehicles onto the road before rush hour.
So in the morning we have about 4 hours to get rid of 100 buses, to get them all out on time, fit for purpose.
This scenario is repeated every day at depots across the capital, servicing 8,500 buses running on over 700 different routes. Sharon's biggest task is making sure all drivers have a functioning bus. By 6 a.m, it's becoming a lot harder.
First thing in the morning, it's easier to control because you've got so many more buses in here in the morning, it's packed. So if anything goes wrong, just tell a driver, quick, take that one, take this bus, take that one. But obviously, as the buses get fewer and fewer in here, if there is a mechanical problem or any problem, it's harder to deal with because we've got a limited amount of buses we can play with.
As the run-out reaches its final phase, the pressure starts to take its toll.
You're gonna have to park up along there. So it can be stressful. And obviously, I'm not just dealing with one route here, I'm dealing with all the routes that come out the garage. So you have to make sure everything leaves on time, all routes, all services. There's hardly any gap in any service.
At times like this, Sheeran needs to draw on all the resources available to him.
It's all part of a team. I'm only as good as the drivers, okay? And the driver's only as good as the buses as well. So we all have to work together, the engineers, the drivers, and the controllers as well.
Today, she's relying on bus driver Nathan Aljo.
Yeah, I'm doing 159 today, duty 284, about 10 minutes early. Just gonna check if there's any diversions or anything.
For Nathan and his fellow drivers, each day is governed by the clock, which starts ticking the moment they arrive on site.
If you're not on time, you could possibly lose your duty and lose a day's money. So it's important that you get it on time. I try to get here 10 minutes early every day.
Once on site, he's allocated a bus. Then Nathan has just 10 minutes to carry out his inspection before it's due on the road. If anything's wrong, his departure will be delayed. It's rush hour. People are depending on him to get to work on time.
All they know is they're out there, they want a bus, bus hasn't come, oh my God, bus hasn't come. When the driver comes, they'll have a go at the driver.
Thankfully for Nathan, his bus passes its check and he makes it out in the nick of time. His bus is vital to people making all kinds of essential journeys.
Working people, going to work, doctors, police, students, everyone really. Everyone needs to get on the bus.
Drivers are the core of the bus service. But if London's buses are to remain the capital's #1 mode of transport, they need help from here.
366 receiving.
This is the iBus control centre in Purley. 39 of these are situated around the capital, keeping a watch over London's bus fleet.
73 you received. 370.
Here, Jeremy Geldard and fellow controllers are in charge of up to 40 separate routes.
Today I'm working with the high frequency, which is I have to make sure a bus is arriving every 10 minutes so the passengers aren't waiting more than 10 minutes for a bus.
To help him, GPS units are attached to every single bus on London's roads. Their positions are relayed back to the centre, where they appear as icons on a screen.
It's almost like being in a helicopter. We could look down and see things and anticipate. The idea of this would to have every single bus in yellow. If every single bus is in yellow, that means there's an even headway, there's a bus every 10 minutes, and every bus is on time. Unfortunately, it's a very rare occurrence for that to happen. We have red and green. Red signifies that the bus is actually too close to the bus in front. So we would ask them to slow down a little bit to create a bigger gap.
Technological advances have changed things dramatically for Jeremy and his colleagues.
When I first started this 10 years ago, we stand on the side of the road and watch buses go past, and we had a little piece of paper in a book and we'd mark off the bus. This bus is on time, this bus is 10 minutes late. Whereas with this system now, we see the whole route in real time. It has been compared to a computer game, basically, because I look at a screen and what I dictate to the screen happens in real life.
That means out here, where Nathan's continuing his morning run. Things are looking clear now, but in London, a congestion crisis is always just around the corner.
When the city is very bad, it can take up to 2 hours to get from Paddington to come off the garage. The traffic will be in central London, and then everyone clogs together.
Exactly the scenario Jeremy wants to avoid. But for now, there's not much Nathan can do.
They shouldn't be too upset with me.
Yeah, 377 is...
A combination of technology and human effort are helping London's buses enjoy a renaissance. For Jeremy and his team, keeping up with London's busy commuters is a daily battle.
But everything seems to be so much faster now. If you want a bus, you want it now. And at the end of the day, that's what we do. It's there as best as we can for them there and then. And that's what city life's all about.
City life needs constant movement. Thousands of people work every day at making it possible for city dwellers to be where they need to be when they need to be there. It's an endless task demanding brain and brawn. Without the army of drivers, diggers, planners and thinkers, our great cities would grind to a halt.